Hi, we're Team 18489, Handsfree Adaptive Keyboard, a multidisciplinary senior design team in the Kate Gleason College of Engineering. We're working with our client, Mavis Irwin, to create a specialized computer interface for people with mobility impairments. The key goals of this project are to produce a device that is A, cost-effective, B, simple to reproduce, and C, does not require any specific software installed on the computer. Our stakeholders are interested in a design that allows a person with a mobility impairment to more easily and seamlessly interact with a computer on a daily basis. Our proposed solution will perform the required keyboard shortcuts of undo, copy, paste, and save, as well as the mouse functions of left and right click and vertical and horizontal scrolling. Our team expects to deliver a fully functioning device that the client can use daily, along with the files and instructions to be able to reproduce this device.
Here's our CAD model. This was designed in Fusion 360 because it's intuitive, free, and it's an industry standard. We have the dovetails here that hold the halves together. The chassis was split into 1, 2, 3, 4 pieces for assembly, and so it fits on any standard print bed. Again, these dovetails here are friction fit, so there's no hardware in the assembly there. We have some screw holes and wiring channels from the bottom and some slots for these adhesive pads for a grippy lower surface so it's not going anywhere when you put it on your table. The hinges here were designed to print in place on their side as one unit, along with the pivot for the throttle. So this prints in one piece with some support material. It's very minimal, so there's no assembly of these moving parts, and that makes the assembly of this very nice, because this prints on the bed this way in about 3 hours for the whole set of 6, and after they come off the bed you remove some of the brim down here for bed adhesion purposes, and then break the movement loose, break the parts loose from each other by actuating them, and that frees them up. After that, they're all ready to go in, no assembly needed.
In order to connect the inputs to the Arduino, two custom circuit boards were made. The first, the L-shaped board, allows for 2 buttons to be connected to the other L-shaped boards and the Arduino. The second, the O-shaped board, allows for a joystick to be soldered on and connected to the Arduino from there.
One of the most difficult decisions that we had to make was to abandon the ability to reprogram the keyboard macros without having to modify the code, as early testing showed that it wasn't likely to work. We adapted by removing the functionality entirely and making it easy to reprogram the Arduino with the new macros specified in the code. Adding this functionality would have required a lot of code that we were not equipped to handle. This allowed us to deliver a fully functional prototype to our client.
Alright, so now time for a demo. As you can see over here, we have the keyboard on the left, and then we have my laptop on the right. And I'm going to demonstrate for you some of the abilities of this keyboard. So over here we have left click, right click. Our customer wanted to left click on the right side because it was closer to the keyboard so they could hit it easier, because it's a more used key. Then we have copy, paste, undo, save, vertical scroll, and horizontal scroll. So I'll demonstrate those in a minute. So I'm going to come over here. I'm going to left click. I'm going to double click to select this text. I'm going to hit copy. Come over here. I'm going to, double click again because it's sheets. Paste. And then as you can see, that worked perfectly. Now if I come over here, I can right click, and I can see my right click menu. I'm not going to select anything because I don't need to. Say I don't want that text there anymore, I'm going to undo. And then if I put it back there and I hit save, we've now saved. And now time for some scrolling. So I'm going to scroll down, scroll up, scroll left, scroll right, back left, and there we go. That's a demo. Thank you very much.
We'd like to thank our client, Mavis Irwin, for giving us this opportunity to put our individual skills together and come up with a product the client can use on a daily basis. We would also like to acknowledge Harold Pashal, our guide throughout this project, the RIT MSD office for assisting us with the design and build, the RIT DSO office for helping facilitate communication between us and our client, and to the Kamerlin Gift for funding this project. Thanks for watching.